everyone! In this video we're going to be looking at a concept called arrays of strings. We know an array is just a collection of objects, and strings are something that we would like to have collections of. So when you make an array of arrays, it's really just a two-dimensional array. So an array of strings is a two-dimensional character array. So character data type, name for the collection, number of strings that we're going to have, because each string is going to get stored in its own row, and then the length of each string, so the number of columns for our two-dimensional array. And then, because strings are a specialized form of array, we can use just the row index for this two-dimensional array to do our string manipulation. So for example, if we wanted the first string to be hello, we can use string copy to set the first row of the array to be hello. So we're going to do a couple of example programs that use this concept, this array of strings. And the first one is going to be a letter frequency. So a lot of times in cryptography, the first thing you'll do if you're given a ciphertext is to try and do a letter frequency, because some letters appear more often in written and spoken word than others. So we're going to try and do a frequency analysis to see which letters appear most often. So we'll be getting our words out of a file, and we're going to store them into an array. We're going to read in 10 of them. So this will be num words. You can see we have that as a constant. Sometimes you'll also see max length. So we can use that to control the sizes of our array. So there can be at most num words, words, and each word can be max length, length, long. And that way we can change it just up here. We'll also allow the user to enter their own file. I'm going to use the mild letter from our previous example, and what we're going to do is just read in 10 words. To make things a little bit easier, we're going to take out the punctuation so that it doesn't confuse our program any. We're going to create a frequency array where we count the number of times each letter appears. So there are 26 letters. And to navigate that, we know we're going to need at least one counter, so we'll go ahead and declare I. Since we're counting letters, we're going to need to look at each element of a two-dimensional array. So we'll go ahead and create a second counter, and then if we need to add anything else, we can return up here later. We'll go ahead and ask for the name of the file, scan that into file name, and then try to open that in read mode. And whenever we're able to open that, that's when we'll break out of the loop. Then we can get all of our words out of the file, because remember, we're only going to read in num words or 10 words. So we're going to read those from IFP, read in strings, and put each one into the ith row of our words two-dimensional array. And since that's all we need out of the file are those 10 words, we can go ahead and close that afterwards. We're going to use a frequency array. It's very important that all of those values start at 0. So we're just going to go through that frequency array real quick and initialize everything to 0. Then we can start traversing the words array and looking for the frequencies of our letters. So like any traversal of a two-dimensional array, this one's going to require nested for loops. Our outer for loop is going to go in the row direction because we need to examine each individual word, and words are stored across a row. Then we can use J to go just the length of that word. We know the maximum length is going to be this max length constant, but each word could have a different length. It could be a short word like the, or a long word like whether, etc. So we just want to do the length of this specific word. So we're going to use string length for our current row and let that be our control. So now we have to decide if we want to do uppercase or lowercase letters. Our file is written in the same way that we would write it. So we uppercase at the beginning of a sentence, the beginning of the word, and everything stays lowercase after that. So we might just stick with lowercase letters, but that means we've got to make ones that are currently uppercase lowercase. So we're going to go into our frequency array. There's 26 spaces, so space 0 is going to be lowercase a, space 1 is going to be lowercase b, so on and so forth until we get to index 25, which will be lowercase c. We're going to get the lowercase form of our current letter. So the current word, to the ith row, the current letter, the jth column. Make that be lowercase with the toLower function. Then make it 0 based. We looked at the ASCII values for characters, so we know that A doesn't actually start at 0. We've got to get down to 0 from our current spot. Cool thing about ASCII is that since it's represented as an integer, we can just subtract the integer value of lowercase a. So that if this value is equal to a minus a is 0. But if this value is equal to c, then c minus a is 2, the index for lowercase c. So we want to go to that index and increment it by 1 to say we found one more of this letter. Once we've gone through all 10 words, we'll have the frequency of all of the letters in all of the words. Which we can then print out. There's two different ways really that we can print this out. We can print out every letter, even though some of them are going to have zeros, or we can print out just the ones that actually have values. So I think we'll take a look at both. So we're going to be retraversing the frequency array, which is 26 spaces. And we're going to be printing out the character that corresponds to the letter, and then the frequency of that letter. Now we can take a look and see the frequency of the letters in the first 10 words of our mild letter. We've got all of our values kind of bunched together. That's just a missing new line character, so we'll add that in. Now we can see frequency of all of our letters. See, some of them are 0. We've got 3 A's, 8 E's, 3 R's, things like that. If we want to, we can get rid of the ones that have a 0 frequency just by saying if the frequency at index I is not equal to 0, then print it, otherwise don't. So this only prints out the letters that actually appeared in those words, so you can see not all of them. E's definitely get printed the most, although at the moment we've just got to look for the numbers. If we wanted to, we could add a little bar chart to make it a little bit easier for us to see which one has the most values next to it. Still want to check to see if there's any value. Then we want to print the character. And then we're going to print any kind of symbol we're interested in for each time that letter appeared. So 8 symbols for E because we had 8 E's in our words. So this way it's really easy to see that E's definitely get printed the most, followed by O's, T's, and H's. And so actually this follows the standard lettered frequency for written words pretty closely. E's and T's are usually very, very common. So in our second example, we're going to sort some books. I've got a list of current popular books according to the internet, and we're going to put them in order lexicographically, which, since they all start with a capital letter, it should be pretty close to alphabetical. So we've got this books text file that we'll use, and now we're going to start mixing strings, arrays of strings, and functions. So we've already defined the functions that we're going to create. One of them is also already written. This is a sorting function, and sorting isn't something that you spend a lot of time studying until the CS1 class. So I've gone ahead and just written that for us, so we don't have to try and understand it. We can just use it, the same as we would the power function. Things we are going to need is something that stores our books. At the moment, we've got a maximum of 10 books, and the greatest length title is allowed to be 80 characters long. You probably saw in our file we're using underscores instead of spaces. That's because C reads to the next instance of white space. So if we want this whole book title to go together, we want to read up to the next occurrence of white space. So we're going to replace spaces with underscores. The only issue with that is underscores do count as characters, so those have to be included in our max length. But since we're using some functions, this might be the only actual data structure that we need. We're going to abstract everything else to our functions. So the first one is going to be read books, which takes in our books array and is going to get all of that information out of a file. So we're going to make a read books function. The only thing that has to be established at the moment is that words is already declared. And this is because we haven't yet looked at dynamic memory allocation. So we have to make sure that the space that we're going to be storing stuff in has already been established. And that's what this declaration does for us in main. We're also going to create in here a file name and a file pointer. We're going to do all of our file work inside this function that kind of takes it out of main. We'll ask for the file of book titles, read that into file name, and use that to open our file in read mode. We'll also create a counter. For now, we're going to do this num books times because that's what we've declared the constant for. We're going to scan a string from the file and store it into our array at row I. And we'll do that 10 times. So this function reads in the book titles from a file and stores them in the words array. So remember, there's a difference between formal parameters and actual parameters. The formal parameter is called words. Our actual parameters is books, but they're going to the same spot in memory. Okay. Before we can test this, we need to be able to print out all of our book titles. So we're going to go ahead and write this print books function, and then we'll test both of them at the same time. So the only purpose of the print books function is to print the title of each book. So we'll print each string and then follow it with a new line coming from the words array at row I. So we're specifying that words is valid. It's already been created, it's already been declared, it's already been initialized. So there's stuff to print before we call the print books function. So we'll print the contents of the array. So now we'll call both of these functions. This one gets the book titles. This one prints the unsorted list. And that's where we're going to leave it for right now. Okay, so my file is called books.txt. So I'm going to have it read books.txt, and it should print out all of the book titles in the same order that they're currently stored. Okay, so there's all of the books, and now we're going to call the sort function that will sort them for us. So we're just going to call sort, and then we're going to print them again now that they should be sorted. So we have both our unsorted list, that one matches the file, and then now we have a sorted list where we should have each of our book titles in alphabetical order. Sorting worked correctly. The last thing we do is figure out the max length. So what's the longest book title we have? So we're going to create this function. So we've got words, it's a sorted list of book titles. we're going to find the longest book title and print the title and the length. So we want to be careful when we're calculating the length to take these guys back out. So we're going to use the C-type library to make sure we're only counting alphabetic characters. So we'll create some counters to traverse the two-dimensional array, and we're going to create a variable called max. And we're also going to have the row that the maximal length title is on. We'll also need something for the current length. So we'll go through each of the book titles, set the current length equal to 0. We'll go through the length of the current book title. So whatever book we're currently on, that's our row counter I. Whatever the length of that word is, we want to check to see if it's an alphabetic character, then we'll actually want to count it. So we'll update current length by adding 1 to it. So string length will give us all of the characters, including these underscores. By doing the isAlpha check, we should only get the letters and not the underscores. So current length should be less than string length. So once we've got the current length, if that is greater than the current maximum, then max should be equal to that length, and row should be the current row that we're on. And we'll repeat that for all of the books in our list. And then before we leave, we'll go ahead and print our results. What is the longest book title and how many characters in it is it? So the longest title is this string with this many characters. So that'll be the book at the row, the one that we've been saving for the maximal value. And max is the maximal number of characters. So now we'll go back up to main and call this function. It's our max length on books, so that it will traverse the books array and find us the one with the longest title. Okay, so it says the longest title is The Empty Throne with 14 characters, which, if you count all the characters in The Empty Throne, is in fact 14. It doesn't count the underscores. Technically that does tie with the Nightingale, but since we used this strictly greater than, it's going to find the first title that is the longest. So it's going to identify the first one, The Empty Throne. So as we continue to add more constructs, you'll find they interact with all of the things we've done before. When we made strings, we know that they were a special type of array, and we can make arrays of strings to get two-dimensional arrays, and we can mix them with functions and files to do cool things like this sorting book program. In our next chapter, we're going to be looking at something called structures, which we use to create unique collections and data types. And as we learn about structures, we'll again see how they can be used with files, arrays, and functions. I'll see you then.